how to calculate peak RMS voltage and frequency of an AC supply using an oscilloscope, or certainly using the pattern that the AC supply provides onto an oscilloscope. What you can see here is the AC supply represented by a sinusoidal wave, which I've managed to keep in one position. Now, as you can see, from the zero line to the amplitude, it's 2.5, 2.5 divisions high. To use the apparatus to calculate the peak, you look at the volts per division setting, and if you can see the volts per division setting, it's set to 1. So 1 volt for each division means 1 volt, 2 volts, 2.5 volts. So that's 2.5 volts peak. And if we use our peak to RMS relationship, do the calculation, 2.5 peak divided by root 2 is 1.8 AC RMS. Now, to calculate the frequency, it's a little bit more complicated. What we need to do is see how many divisions from left to right one full wavelength is. Now, as close as I can get it, from peak to peak, which is one wavelength, looks to be 1 to, say, 2.5 divisions. Now, this setting over here, the time base, or the time per division, tells you how many seconds it takes the wave to travel from one box left to right. Now, this is set at 2 milliseconds for each division, which means that wave has taken approximately 5 milliseconds to travel from left to right. So if it's 5 milliseconds from peak to peak, then that's the time period of the wave, time for one complete wave. Because we know that time period equals 1 over frequency, and if we do the calculation, if the time is 5 milliseconds, then the frequency is 1 over 5 milliseconds, which is 200 Hertz.